Good everyone, in this video I'm going to be showing us how to design and model a database like a professional. My name is Stanley and I'm the founder of Stanalytics, and today I'll be walking us through how to design and model a database like a professional. Now we are going to be using our Excel, we are going to be using our sales data sets generated from Kaggle, and we are going to be working on it to create our data model. So when designing and modeling a database, you have to go through three phases, which is the conceptual model, the logical model, and the physical model. Now, what is the conceptual model? The conceptual model is the phase where you are going to ask the basic questions like what do you want to keep track of. So you are going to want to store the sales data set, which means that we've obviously gathered our sales related data. So that question has been answered. Then the next question we want to answer in the conceptual model is how do we want to store our data, like how are they related to each other. So that is where the breakdown comes into play. So and that is where you start imagining the ER diagram, the entity relationship diagrams. So how are they related? It's talking about how each entity is related to each other, and we all know that this is a sales database. Is going to have the sales entity, is going to have the customer entity, the product entity, and the sales rep entity. So what they're trying to say is that how does the sales entity relate to the sales rep entity, for example. And we all know that for a standard company, a sales can have so many sales rep attending to it. So and so as the product, so one product can have many sales. So you can see that we're starting to build a conceptual view towards our data sets. Then the next thing is the logical diagram, which is basically an how question. So how do we represent them in a schema? So how are we going to store them in the database? Which attributes are going to be stored on each entity? So and we also talk about the primary and foreign keys. The primary key? Primary key are unique identifiers. So they basically identify each product. For example, let's say for a product entity, each product has an ID. For example, a furniture purchased has an ID different from a food purchased. So you can see here that this is a product ID. You can see that this is 1052. No other rows, what I mean by row is this is a row, for example, this is another row. No row can have this same number, this same ID. It's just like a matric number for the students. So and there's also a foreign key. So a foreign key is what references. For example, let's say we are trying to study a relationship between a sales and a sales management and a sales person. So we can see that a salesperson ID is going to be in the sales table, indicating that is a foreign key, which means that it is the one in charge of joining the sales table and the salesperson table. So without the foreign key, there is nothing linking or establishing the relationship between the sales and the salesperson relationship. So moving on to the MySQL, which is actually the stage where we built the database, and we all know that MySQL is an RDBMS, so it's a relational database management system. So it is where we store our data. It is the management system that gives us access to the database, which allows us to store the data, manage the data, update the data, and it is a key for us to interact with our data and our database. So moving on, we go to MySQL, click on this ER diagram, then click on add model. Then in this my DB, we have to rename it. So rename it to a sales. Rename it to sales. Then click on add diagram. So this is the logical model we're already building. So we've already established imaginary how the data is going to be stored in the database using the conceptual model, and you've already also like drafted each attributes that are going to be stored in the database using the logical model. So this is actually like putting the logical model into reality. So this is the logical model. So we've already done the conceptual model, which is basically like mapping out the data that is going to be stored and how they are going to be related to each other, which is basically the breakdown of each data. So, and the logical model talks about the attributes of each entity, like each data, for example, sales data, salesperson data set. So the first entity we are going to be working on is the sales entity. So click on this table and drag it. Then we rename our table sales. Yeah, it's going to be sales. So for clarification, we can rename it sales underscore table. So then we start defining the attributes. So it's going to have an ID, obviously. So we're going to have an ID, obviously. So sales underscore ID, and it's going to be an integer, and it's going to be our primary key, which is going to uniquely identify each rows. Then sales dates. So this is the logical model. Like I said, like I've been saying, it's the logical model. So it's not, we don't want to have a null value, because obviously each sales we make in a company will have the date that the sales was actually made. So having a null value will indicate that there is something wrong somewhere and we need to investigate. So it also needs to have the sales amount and the discount. So amount, and it's obviously an integer. So right, this is a date. So then discounts, also an integer. So we've created our sales table. So if we created our sales table, it remains the sales rep, the customers, and the product table. So like you said in the conceptual view, we break down our data into relationships, right? So another easy way to create a table is just to press T on your keyboard. So we'll name our new table product. So right, and obviously it's going to contain a product ID. So product underscore ID. So and it's going to be our primary key, and it's not. Then it's going to contain a product category, right? Obviously each product is going to have a category like we have in our data set. So you can see a product category is in our data set. So let's rename it product underscore category. So it's going to be a voucher, obviously. So then unit cost. That means if like price for each product. So unit cost is going to be an integer, obviously. So we change our data type to an integer. Then not no. Yeah, so the next thing for us to do is to create our sales reps table, right? So press T again on our keyboard and tap it. And you can see that a table has been generated. Your name is sales rep, right? It's going to have an ID. So basically every table you create on MySQL, every table you create in your logical model must have an ID and a foreign key. So we've discussed this basically. So an ID uniquely identifies each column, and the foreign key references a table like in another table. Like it's a foreign key allows us to access the relationship. So for a relationship to exist, there must be a foreign key of like one of the entities ID in another table. So I'm going to show you and I'm going to explain it. So like when I start establishing the relationship, because basically in the conceptual model, one of the questions we are going to be asked was how does our entities, which is the what we are trying to store, how does they relate to each other. So the sales rep, so sales rep underscore ID, so it's going to have an integer and not none. Then the region, now it's time for us to define the relationship. So if you go under these indexes, you're going to see that the primary, and analyze the primary, we're going to see the product ID. So that means the product ID is the primary key. You can do the same thing for this. So the sales table. Now for the relationship, we have three different types of relationship. We have the one-to-many, the one-to-one, and the many-to-one relationship. So I've explained those relationship types in this slide, so we don't really have to like go over it again. Now one sales can have many sales reps being attended to. So that is as a many to one relationship, right? So one sales, many sales rep, one sales, many products. So and another thing is when you're creating your database, is all that matters is how your manager wants the database to be stored. It is your manager that is going to define the conceptual and the logical model, not you. So if the manager wants many relationship between the sales and products instead of the many to one relationship, that's how you want his database to be stored. There is no question about that. So now moving on. So in this sales and products relationship, we can decide to be that okay, one product can only be limited to one sales. So one product per sales. For example, let's say you buy a furniture, that means you bought a product, so one sales per one product. So and basically what I'm trying to say is like one product per product category. So per category, like for the furniture category, it can only have one sales, which is basically like might not really be realistic considering your company. So it depends on what your company wants. Basically, if your company wants like many sales in one category, like for example the furniture category, you have the chairs, you have the tables, and a lot of things. So you can decide to sell more, like you can decide to have many sales coming from one category, right? So the company might actually be a type of company that they produce only chairs, so which is a one furniture category. So definitely, obviously, they're going to have just one sales per one category, which is the furniture, which is the chair category. Now, let's say the sales company is producing chairs, tables, and other furnitures. They're going to have many sales per products category. So that's why it's going to be a many to one relationship. So highlight this relationship, then drag. So you can see that this table, this one I'm highlighting is the foreign key that's established a relationship between the products and the sales table. And you can see that when you highlight this product ID, you can see a diamond shape here is indicating a foreign key, which is an ID of this product. So this product ID, has saved itself in the sales table, representing a foreign key. So anytime you are trying to establish a relationship between two tables, the tables that has that starts the relationship is going to have its ID in the second table, standing in as a foreign key, which is indicating that a relationship has been established. So whenever there's a relationship between two tables, you are going to have the primary key, which is the ID of the first table, in the second table. Now also a sales rep and sales. So one sales rep can attend to many sales, right? That's a many to one relationship. So establish it also. Then okay, you have to delete. Yeah, so we are done the conceptual and the logical model. Now it's time for us to use the actual database. So this is a structure of how our database looks like. Now it's time for us to actually create the database and let our database be live. So we have to do is just go to the database, forward engineer, then wait for a little while, then click on next. It's going to ask you to input your password. So click on next. Mm. So there was an error initially when I was creating a database. So now actually creating a database, you click on a database like so. It's because of there are some empty cells there that they don't have a name, and MySQL doesn't really go well with like an empty colon name. So if you create an attribute which is basically a colon in MySQL, it's going to have a name, just like in Excel creating a row without a name. So it doesn't work that way. So moving on, you go to our database, forward engineer. Then next. Then click on next. So actually this MySQL is basically using the query to build your database. So and sometimes it's not uncommon for errors to happen. So I've kind of corrected my query and I've drafted the correct one. So click on next, then close. Then now if you go back to your home button, then connect to your database. So you can see it says sales. So let's just refresh it. Then tables, you can see these are the tables you created: product, sales rep, and sales table. So now in MySQL, if you want to check all the databases you've created, just write show database. So these are all the database I have created personally on this workbench. So thank you very much for watching and have a nice day. So if you have any question, you can let me know. So until then, I see you on the next class.